Okay, 6.2b. I have some different notes here. Hopefully this will help things go through a little cleaner. A couple things we need to know before we get started. First off, 1 mile is equal to 5,280 feet. Okay, and in our first problem, we're actually going to see that we need to deal with inches. So I'm going to say that 1 mile is also equal to, I'm going to take that 5,280 feet and multiply it by 12, and I get 63,360 inches. Okay, so I'm going to need that for the first one. So, if the tires on John's bicycle have a diameter of 30 inches, what does that tell me straight off? It tells me my radius is 15. Okay, I'm going to need my radius. And during warm-ups are turning at a rate of 141 revolutions per minute. Okay, revolutions per minute. Determine the bicycle's speed in miles per hour. That is a linear speed. So I'm looking at my V equals R times theta over T formula. Now I don't have a theta though, that's the problem. I have revolutions per minute, but I do not have a degree. So how do I change revolutions per minute into a angle measurement? Sorry, not a degree, a radian. I need to take 141 revolutions per minute. I'm going to say theta equals, because that's what we're solving for. And I need to multiply that by 2 pi. That will give me the number, or the degree measure that's covered, or the radian measure that's covered in that many revolutions. So 141 times 2 pi is 885, we'll call it 885.9. 0.9 radians per minute. Okay, so now let's plug this into our formula. So our velocity, linear velocity, miles per hour is a linear measurement, miles is linear, not an angle, is 15 times theta, which we just decided was 885.9, all over the time, which in this case is currently 1 minute, right? Radians per minute. So what do I get when I multiply that out? 15 times, actually I can just do this, times 15, because there's the 885, and then divided by 1 is just that, right? So let me round that off. 13,289 we'll call it. And that's how many inches are traveled in 1 minute, because we multiplied theta by 15 inches. Yes? So I have a speed now. I have a velocity. The problem is it's not in miles per hour, it's in inches per minute. So I have a little bit of work I need to do. So let me write this over here. 13289 inches over 1 minute. Now I'm going to multiply this by a set of fractions, and these fractions all have to have an equivalent measurement on top and bottom, but I need to get inches to end up canceling out and equaling miles, and I need to get minutes to cancel out and equal hours. So I'm going to start with the inches. What do I know about a mile? Well, we've decided this at the beginning. 1 mile is 63,360 inches. So miles is where we're going. So I want inches to cancel out. So I'm going to put inches on the bottom because that's how things cancel, right? One on top, one on bottom. And I'm going to put miles on the top. So in 1 mile, there are 63,360 inches. Notice just the inches are canceling out. The numbers are going to stay the same. Okay? So I've canceled out the inches and now I have miles. So now I'm going to go to, this was dealing with the distance part. Now I'm going to deal with the time part. 1 minute, I need to change to an hour. I need minutes to cancel out, so I'm going to have minutes up here, right? So they will cancel. And I'm going to have hours down here. How many minutes are in 1 hour? Well, that's 60 minutes in 1 hour. So do you see how the only units of measure left are miles and hours? That means when I multiply here, I'm going to end up with miles per hour. So all I need to do at this point is multiply straight across the top and then divide by what I get when I multiply straight across the bottom. So I'm going to do this divided by this and watch what that does. So the 13,288.93, we'll leave the 0.93, that's fine, times 1 times 60, that's what I have on the top, divided by, I'm going to put parentheses around the bottom, 1 times 63,360 times another 1, and I get my answer of we'll call it 12.6. I have 12.6 miles per hour, also known as mph, or you could do m over h, or I should say mi, because m is typically meters. Okay, so that's how I do that one right there. Okay, moving on to number 2. A pulley is turned at 120 degrees per second. So this is our angle measure, and then we're going per second. We need to change it to revolutions per minute. So I'm going to write it down. I'm going to be doing this thing here, this conversion again. So 120 degrees is how far it travels in 1 second. Now, that's not radians. Is that an issue? Not really. You can do it in degrees or in radians because all we're doing is changing it to revolutions per minute. If I was in radians, I would use 2 pi, but since I'm in degrees, I'm going to use 360. So, excuse me. So I know that 1 revolution is 360 degrees, right? Now, why did I write the revolutions on top and the degrees on the bottom? Because I want the degrees to cancel out, because there are no degrees in revolutions per minute. I have revolutions, which is half the battle. Now I need to figure out minutes, and I'm currently in seconds. Seconds are on the bottom, so I need seconds to be on the top, and I need minutes to be on the bottom. So 1 minute on the bottom. I should have written that more towards the middle, but that's okay. And how many seconds are in 1 minute? Well, there's 60 seconds in 1 minute. So if my seconds cancel out and my degrees cancel out, I'm left with revolutions per minute. So all I have to do is multiply across the top and divide by multiplying across the bottom. So on the top, I have 120 times 60, that's 7,200, divided by, on the bottom, 1 times 360 times 1, again the ones are kind of irrelevant, I end up with 20 revolutions per minute as my answer there. Okay? Now the second part of this says, if the radius of the pulley is 5 inches, find the linear velocity in inches per second. So inches, we're good. Notice this was per second. Sorry, you can't see that. Per second, this is also per second, so we can use the 120 degrees to our advantage. Now, linear velocity, as we saw earlier, is r times theta over t. Now, since we're calculating a velocity, theta does need to be in radians now. It didn't need to be in radians when we were just converting it to a different unit of measure, but now that we're actually calculating with it, we have to do it in radians. So 120 degrees, first thing I'm going to do is convert it to radians, and I do that by how? Multiplying by pi over 180. So that gives me 120 pi over 180, which simplifies to, if I divide by 60, I get 2 pi over 3. So let's think about this. My velocity is going to be equal to the radius, which is 5 inches, times theta over time. Well, 120 degrees per second is the same thing as 2 pi over 3 radians per second. Right? So really, it's just 5 times 2 pi over 3 on top and 1 times 1 on the bottom. So I don't even need to think about the bottom. I can just do 5 times 2 pi over 3. Now I do always suggest putting parentheses when you have a fraction, just to make sure it calculates it the way you need to it. And I got 10 point, we'll call that 10.5 And what are we talking about? Inches per second. Okay, so that's our answer for 2B. All right, number 3. The diameter of a Ferris wheel is 80 feet. Again, that tells me immediately the radius is 40 feet. If the Ferris wheel makes 1 revolution every 45 seconds, find the linear velocity of a person riding the Ferris wheel. Okay? Linear velocity, again, we've used that formula a couple times, once up here and once over here. So linear velocity is equal to the radius times theta over t. So in this case, the velocity is going to equal, my radius is 40 feet, times theta. What's the angle covered? Well, I know that it's 1 revolution every 45 seconds. So I know that time is 45 seconds. If it's 1 revolution in 45 seconds, the degree measure of 1 revolution, or the angle measure, would be 2 pi radians. That's a full revolution in 45 seconds. So I just need to multiply 40 times 2 pi over 45, and I already did that over here. I end up with 5.58, we'll call that 5.6, and we're in feet per second, so feet per second. Okay? And the last part, suppose the linear velocity of a person is 8 feet per second. So that's how fast they're traveling. What is the time for 1 revolution of the Ferris wheel? Well, I know that 1 revolution is a full circumference, which is 2 pi r. That's how the person would be traveling around the outside, right? When they completed 1 full rotation, they would complete 2 pi r as a distance. So 2 times pi times the radius, which we determined up here was 40 feet, gives me 80 pi feet. Yes, you could go to decimal, doesn't really matter. So this person is going 80 pi feet to complete 1 revolution. That is the equivalent of completing 1 revolution. But they are only moving 8 feet per second, so if I divide that by that 8 feet per second, I get what? 10 pi feet? Well, 10 times 3.14 is 31.4, so approximately 31 seconds is how many seconds it's going to take them. Okay? So again, the reason why it becomes feet per second is because you have feet per second here. Well, that's going to cancel, and you're just left with seconds, and that's going to end up bumping to the top because since it's on the bottom of the bottom, confusing, but the bottom, if you have a division thing, a fraction there, the bottom part of it ends up bumping to the top. So don't be super concerned about that. Again, the time for 1 revolution is 31 seconds. All right, happy studying.